Welcome back to a course on calculus in which we are talking about differentiation now. The lecture is about chain rule. The chain rule tells us that suppose f is a continuous function on the closed interval a b and f prime of x exists at some point x in the interval, and g is another function which is defined on any interval I, but the interval must contain the range of the function f, right? And moreover, g is differentiable at the point f of x. If we have all these things and we define the composition of these two functions, that is g of x, g of f. Okay, g composite f we are defining and we are denoting that as h. And if these things are there, then we can have the derivative of this function h of x, that is the composition of these two functions in the given format. This is what we are going to prove in this theorem. Let us start the proof. Given f is differentiable at x in AB, this means limit t approaches x, f of t minus f of x upon t minus x exists, and that one we are denoting it as f prime of x. And given g is differentiable at f of x, and here let us take f of x to be y. Thus we are rephrasing this as g of something minus g of f of x, and that f of x we are writing it as y upon something minus y. This is what we are going to have, and this one we are going to write it as g prime of y. This is some dummy variable, right? So let us denote that as s. Even if we have t, that is no bother, but some of us may get a confusion that this t is taken in this interval. This s is something different, not this interval. Okay, even if we denote t here, that is not a bother, but we'll have a confusion that this t is a notation that is used to denote some value between a and b. That is why we have taken another notation. So this is limit s approaches y. In simpler notation, this s may be taken as f of t. Okay, that will come back when the proof proceeds. Okay, so having these things in our mind, we shall rewrite them as, okay, f of t minus f of x upon t minus x is f prime of x plus some function u of t. This u of t approaches 0 as t approaches x. Okay, this is a valid point, right? So limit is the approximation. That approximation we don't know what it is. For how much we close, how much closure we take the approximation, based on that we have some function u. And similarly, g of s minus g of y upon s minus y shall be written as g prime of y plus some v of s. Here this v of s also goes to 0 as s approaches y. Okay, from these two, what we are writing is that f of t minus f of x shall be written as f prime of x. Okay, let me put this way: t minus x times of f prime of x plus u of t, and this g of s minus g of y shall be put in the form of s minus y upon g prime of y plus v of s. Okay, now we come to the things. Here these things are defined for t in the interval a b. S is a member of I. We don't know what this I, but this I contains the range of the function f. Therefore, we shall take f of t to be S. right? So having this in mind, let us consider h of t minus h of x. This is nothing but what? G of f of t minus g of f of x. This is simply g of s minus g of y. So h of t minus h of x is g of s minus g of y. That is nothing but s minus y times of g prime of y plus v of s. Okay, and what is this s? This is f of t and this is f of x, and y is what? F of x plus this is v of f of t, right? Now we'll have to substitute the value of f of t minus f of x as well. Therefore our h of t minus h of x becomes, okay, let me write the things that was there in the previous step too. So this thing along with g prime of f of x plus v of f of t, right? Okay, so this is t minus x times of, this is t minus x times of f prime of x plus u of t times of g prime of f of x plus v of f of t. Okay, and this tells you your h of t minus h of x upon t minus x is f prime of x plus u of t g prime of f of x plus v of f of t. Now let us take limit t approaches x, h of t minus h of x, t minus x. So this is, let me do the things separately. That is, I am making use of the algebra of functions now. Here, first of all, we'll have to apply the product rule of limits and then the sum rule. So as of now, let me write only the product rule. So this becomes like this. Right? Here, what are the things that we are going to make use? This is independent of t. So this remains as it is. Okay. This u of t goes to 0 as t approaches x. So this quantity is 0. So plus 0. Right? Multiplied with, this is also independent of t. So we have simply g prime of f of x plus, here what is going to happen? As t approaches x and f is continuous at t, f of t is f of s. Sorry, yeah, f of t we shall take it as s, right? So what happens here? We have as t approaches x, this means what? This is similar to s approaches to y. So this goes to 0. So this is going to be 0. This is 0. So finally what we have is f prime of x times of g prime of f of x. And this is simply what? H prime of x. So finally what we have is h prime of x is f prime of x times of g prime of f of x. Hence h is differentiable at t is x, and this completes the proof. Okay, thank you.